Hello and welcome to Learn ADS in 5 minutes. This is tutorial 36 on DC simulations in ADS. What you will learn in next few minutes is listed here, and we will go over almost all the aspects of running DC simulation in ADS to find out how to do DC IV characteristic simulation, plotting load line, annotating DC current and voltages on the schematic, and also look at device operating conditions. Before we get started, subscribe to my channel. Once you subscribe, click on the bell icon to enable all the notifications. And after watching the video, don't forget to hit the like button and share it with your colleagues and friends. Now let's get back to our agenda here and go through all the key steps in running DC simulation inside ADS. Now we will start with creating a new workspace and we will call it DC simulations. And to run DC simulation, basically you need a nonlinear component model. And for that purpose, we will go ahead and use a demo kit, which ships along with ADS. Using one of the earlier videos, if you have your own vendor component library, you could go ahead and include that to obtain the nonlinear component. After we have the workspace, we can go ahead and create a schematic. And in the schematic, we can see the library palette for the thing which we added while creating workspace. And here we do have a fit component, which we will use as a demo example device to run through various simulations. Now notice this fit has create in and source terminal. Depending on the config in which you want to apply the DC, we can go ahead and now set it up. Now for DC, we need a DC voltage source or the current source, and those can be obtained from one of the sources library. We do have a voltage source, we do have a current source and so on. So we can use to provide bias to our device. And also all the simulation related item can be found under simulation DC library palette. And basically what you need is just a DC simulation controller to be placed on a schematic. However, if you want to run a parameter sweep, we can have a parameter sweep to allow more than one parameter to be swept during DC simulation as we would need for IV characteristics. Now, in order to prepare our circuit for IV characteristics, the quickest or the simplest way to do that is by going to insert template, and from here we do have a couple of simulation templates which can be used by designers. One is BJT curve tracer, which we can use for BJT or HBT kind of devices. And the second one is FET curve tracer, which can be used for performing IV characteristics on FET, PHEMS or MOSFET kind of devices. Now using this template, we can notice the infrastructure already in place, and we can just place our FET device and start wiring it at the right location where we need. So we will provide the gate drain bias to the drain terminal, connect the gate, and then these two sources, because we want to run in a common source configuration, we will short these two sources and then connect it to ground. So that's why very simply our device is connected and we are ready to perform a DC IV characteristics. Now here notice with every simulation controller, we will have opportunity to sweep one parameter. So in this case, we want VDS to be on x-axis. That's why we define parameter of VDS to be swept in the DC controller. And we set it up from 0 to 5 volts in a step of 0.1. And we want VGS to be outer variable. That's how a classical IV curve for a FET device, where for a particular value of VGS, we will go ahead and sweep VDS to obtain one IV characteristics. And then we keep changing VGS to different values and obtain multiple graphs. So here for VGS, I'm going to define the range as 0 to minus 2.4 and in a step of 0.2. And notice we also have a display template included in the schematic so that once we finish simulation, and we will have a data display already plotted. Now, depending on what kind of library you are using, some library components are straightforward to use. However, some library components need a tech include or the model include component to be placed. So here in this library, we do have a tech include component, and we'll select the technology associated with it. So this tech include basically has the nonlinear model for this device. And now when we run simulation, the simulation finishes successfully. And now you can see the IV characteristics. So we'll go ahead and modify this, plot slightly so that we have the right, representation. So here you can notice the VDS is on x-axis and these are the separate VGS values. And that's why we defined VGS in the parameter sweep and VDS in the DC simulation controller. We already have a marker, and when we change the marker, we can notice the power consumption and the appropriate VDS value here. So we'll go ahead and place the marker near the cutoff region here, and we will add a new marker on the knee, voltage point or the knee current point. Now with these two markers, if you want to plot a DC load line, we just need to draw a line connecting these two markers, and then we can read the slope, and our load resistance will be negative reciprocal of that slope. Now in order to do that, it's kind of very simple by writing 2, 3 equations, and I already have a template done here, which is giving those equations. So here I have a DC load line, and these equations basically compute the DC load line depending on the marker location. So first we calculate the slope, which is basically delta y. M1 and M2 are the y-axis values. You can see both M1 as well as M2 gives the y-axis value as well as x-axis value. So M1 minus M2 gives you delta Y, and in-depth M1 and in-depth of M2 gives you delta X. So by doing delta Y by X, we can simply calculate the slope, and rest everything is pretty self-explanatory. And here is our load line with a variable name line. So we can double click on the graph, going to equations, we can pick the line and we can add the line on the same graph. And now we have the DC load line. Now this R load gets calculated as a negative inverse of the slope, and we can just simply insert a table on the graph, and then we can plot the R load from equations, and that shows us depending on the marker location what is the slope or what is the resistance of this device shown at the output. And depending on the class of operation or the biasing class, we can come up with newer and newer value. Just a word of caution here. This is only DC load line, not a dynamic load line or a AC load line, because right now we are not providing any kind of sinusoid or any signal or a AC signal to the device. This is purely a DC characteristics, which is a good starting point. But as you will see as we go along, we will be able to plot dynamic load lines to see how the envelope changes according to the signal amplitude. Right, so this finishes a couple of points which we set out originally. Now we will look at how to do voltage and current annotation on the schematic, and then how to find at what operating condition my device is operating on. So to annotate DC condition, we can go to simulate, and under simulate we do have a DC annotation, and we should be able to annotate the voltage, current, or the device operating point from here. So if we click on annotate voltage, we can see the voltage annotation. And also there is a toolbar here. If you right click and switch on the DC annotation toolbar, you can notice these pellets come along with the toolbar. Now we can click here to annotate the current, and we can click here to find the DC operating point. But although we are running sweep, but it is still showing only one number. So the question is, how can we see voltage and current at various, kind of, sweep points? And that can be done by going to simulation settings. Under simulation setting, you have DC annotation option. And here I will ask ADS to collect detailed information on the operating point, and also save all the DC solutions so that we can pick the voltage combination on which we would like to annotate the circuit diagram. So once we do this, we can go ahead and simulate this circuit again. And now, depending upon the various levels, we would be able to select the right combination for which we would like to do the plot. So here under DC, operating condition, by default, as you can see, it is selecting first sweep point to annotate. And in this case, I can go ahead and pick any other combination where I would like to see voltage and current. For example, if I would like to see at VGS -2 and VDS of 3 volts, and as soon as we select this, you can notice the annotation gets updated. So if you miss that, let me try repeating it. So if I select another combination, you can see the annotation is kind of changing. So this way we can quickly find out the right voltage and current information. Now for DC operating condition, if we click on operating point and click on the device, it gives us the detailed information like ID, IG, IS, GM, CDS, GDS, and all those internal information so that we know at particular bias condition, how is my internal operating condition for this particular device. So with this, we come to an end of this tutorial video. Thanks a lot for watching and hope it was useful for your work. And don't forget to hit the like button if you like the content presented and subscribe to my channel. See you in the next tutorial video. Thanks for watching.